NASA just confirmed something about a comet that should not exist. It might be older than the Sun itself, not by a few 100 million years, but potentially by 6 billion years or more. And the James Webb Space Telescope just proved it by reading the actual chemistry frozen inside it. This is not speculation. This is not a YouTube theory. This is data published, peer-reviewed, and confirmed by multiple space agencies working together. Stay with me for the next few minutes because what Webb found inside this object rewrites what we thought we understood about visitors from other stars. And if you want the real confirmed science on stories like this, delivered before the clickbait channels get around to butchering it, hit follow right now, because that is exactly what this channel exists to do. Let's start with the basics, in plain simple words, so everyone is on the same page before this gets genuinely strange. Our solar system has one sun, 8 planets, a collection of moons, and countless smaller objects like asteroids and comets, and every single one of them is bound by the sun's gravity. They all loop around our star in paths that repeat year after year for billions of years. That is what it means to belong here. Gravity keeps pulling you back. But every once in a while, something shows up that does not belong here at all, something that formed somewhere else entirely, around a different star, in a different part of the galaxy, and is only passing through our neighborhood once before it leaves forever. Astronomers call these interstellar objects, and in all of recorded human history, we have only ever confirmed 3 of them. The first one showed up in 2017. It was small, strangely elongated, and tumbled through space in a way that puzzled scientists for years afterward. It showed almost no visible activity, no gas, no dust, nothing streaming off it, the way a normal comet behaves, and by the time telescopes were fully trained on it, it was already too faint and too far away to study properly. It left more questions than answers, and parts of its behavior are still debated to this day, simply because there was not enough time to gather real data before it vanished. The second interstellar object arrived 2 years later in 2019. This one behaved much more like a familiar comet, with a glowing coma and a visible tail. Because it was more active, scientists managed to collect a richer set of data on its chemistry. But just like the first visitor, it was already on its way out by the time serious observation began, which limited exactly how much could be learned before it slipped back into deep space for good. Both of those encounters left scientists hungry for a third opportunity, a bigger, brighter, more active interstellar object that would give the world's best instruments, including tools that did not even exist back in 2017, enough time and enough light to get a proper, detailed look. On July 1st, 2025, that opportunity arrived. Telescopes at a survey station in Rio Hurtado, Chile, part of a network called the Asteroid Terrestrial Impact Last Alert System, flagged a faint, fast-moving point of light. Within days, astronomers confirmed it. This object was moving far too fast to be trapped by the sun's gravity. It was never going to loop back, around. It was going to pass through and keep going, out into deep space, never to return. This was the third confirmed interstellar object in recorded human history, and it was named 3I/Atlas, with the number 3 marking it as the third of its kind, an atlas honoring the survey system that first caught sight of it. Almost immediately, something about this visitor stood out. Its path around the sun was more extreme, more sharply bent than either of the 2 interstellar objects before it. In simple terms, the shape of an object's orbit tells you how attached it is to the sun's gravity. A path that curves gently and loops back means the object belongs here. A path that comes in fast, bends only slightly, and shoots straight back out means it is only passing through. 3I/Atlas had the most extreme hyperbolic path ever measured for an interstellar object. It was traveling at well over 200,000 kilometers per hour when it was first discovered, and it only accelerated as it fell closer toward the sun, eventually becoming, by some measurements, the fastest interstellar object ever recorded crossing our solar system. Here is where the story gets genuinely shocking, and it is the reason I opened with that line about the sun. By measuring how fast this object is moving relative to the average motion of stars in our region of the galaxy, scientists could estimate roughly how long it has been drifting through interstellar space since it was first flung out of whatever star system originally built it. The earliest estimates placed its age somewhere between 3 billion and 11 billion years old. For comparison, our own sun and solar system are about 4.5 billion years old. That already meant it was entirely possible this comet was older than our sun. But then, in June of 2026, a new peer-reviewed paper published in the journal Nature pushed that estimate even further. Using fresh spectroscopic data gathered by Webb as the comet was heading back out of the solar system, researchers now believe 3I/Atlas is somewhere between 10 and 12 billion years old. That is nearly 3 times the age of our entire solar system. Sit with that for a second. A frozen chunk of another star system, built roughly 10 billion years ago, drifted alone through the empty dark for essentially the entire history of the Milky Way, and it just so happened to cross paths with Earth during the exact narrow window in human history when we had telescopes powerful enough to notice. Unlike the first interstellar visitor, which looked mostly quiet and rocky, 3I/ATLAS turned out to be a genuinely active comet. As it approached the Sun, frozen material on its surface began turning directly into gas, streaming away and forming a glowing coma along with a faint tail. This mattered enormously to scientists, because an active object releases its internal chemistry into space, where telescopes can actually detect and analyze it. A quiet, inactive rock does not give up its secrets. An active, outgassing comet practically hands them over. It is also worth appreciating how much coordinated effort it took just to find this thing in the first place. The survey system that caught it scans huge portions of the night sky every single clear night, comparing each new image against the one before it, hunting for anything that moved. Most of what it catches are ordinary asteroids orbiting harmlessly within our own solar system. Catching a genuine interstellar object is an enormous bonus, a single needle in an almost unimaginably large haystack of nightly sky images. And because the system caught 3I/ATLAS early, astronomers worldwide had months of advance warning before its closest approach to the Sun, something they never really had with the first two visitors. That lead time meant space agencies could schedule time on some of the most in-demand telescopes on Earth and in orbit, months ahead of the comet's closest pass, instead of scrambling at the last second the way teams had to back in 2017. Before we go further, if you are finding this genuinely interesting, drop a follow now, because we are about to get into exactly what the James Webb Space Telescope found when it turned its instruments toward this ancient visitor, and it goes far beyond what most people online are talking about. What came back from those observations stunned a lot of scientists. The comet's chemistry did not look like anything from our own solar system. For one, it showed an unusually high amount of carbon dioxide compared to water vapor, a ratio that broke the pattern astronomers have documented in solar system comets for decades. That alone told researchers that whatever environment originally built this object was chemically different from the one that built the comets native to our own neighborhood. Then came an even bigger discovery. Deep in the mid-infrared data, scientists identified the clear signature of methane gas streaming from the comet in mid and late December, roughly 2 months after the comet's closest approach to the Sun. This marked the first time methane has ever been directly detected coming from an interstellar object, and researchers found that the amount of methane relative to water was surprisingly high compared to typical solar system comets. Alongside the methane and carbon dioxide, Webb also picked up a clear signal of water vapor, plus something genuinely unexpected, a very specific atomic signature belonging to nickel. Finding a metal like nickel escaping in gas form from a comet is unusual, and it tells scientists something about the raw ingredients mixed into this object roughly 10 billion years ago in a completely different star system than our own. To understand why methane matters so much, think about what methane actually is. It is a simple, lightweight, fragile molecule. When exposed to raw cosmic radiation over long stretches of time, exactly the kind of radiation an object drifting alone through interstellar space for billions of years would face constantly with nothing to shield it, methane tends to break down. Scientists did not necessarily expect much of it to survive on the outer surface of an object this old. Finding a strong, clear signal of it was a genuine surprise, and it forced researchers to think carefully about where exactly it was coming from. The leading explanation is that the outer layers of the comet lost most of their original methane over billions of years of exposure, and what Webb was picking up was methane escaping from deeper, unprocessed material underneath the surface, material that had been shielded from radiation the entire time, and was only now being exposed as the comet's outer layers boiled away in the heat of our Sun. In simple terms, Webb was not just looking at the surface of this ancient visitor. It was looking straight into material that had been locked away, untouched, since before our own solar system even existed. But the story does not stop there, and this is the part almost nobody outside of specialist science outlets has fully covered yet. In June of 2026, researchers published a follow-up study in Nature that pushed the mystery even further using Webb's near-infrared spectrograph, known as NIR-SPEC. As the comet moved away from the Sun in December of 2025, its ancient ice had been freshly warmed and converted into a bright coma of gas, giving Webb close to ideal conditions to measure something incredibly subtle: the ratio of ordinary hydrogen to a heavier version of hydrogen called deuterium, sometimes nicknamed heavy hydrogen. Webb captured detailed data, including chemical ratios of carbon and deuterium, that simply are not found in comets from our own solar system, and the results genuinely surprised the researchers involved. Specifically, Webb's instrument revealed deuterium levels roughly 30 times higher than what astronomers typically measure in solar system comets. Why does that number matter so much? Deuterium forms in specific conditions, mostly locked into molecules when temperatures are extremely cold, colder than almost anywhere in our own solar system ever gets. A comet carrying this much heavy hydrogen is essentially carrying a thermometer reading from the exact environment it formed in, and that reading points to somewhere far colder and far more ancient than the birthplace of any comet we have ever studied up close. Researchers described it as an unexpectedly high level of enrichment, calling it an exceedingly rare detection of deuterated organic molecules in any interstellar object. Some of the earlier measurements from earlier in 2026 had already found a deuterium to hydrogen ratio in the comet's water of nearly 1%, more than 10 times higher than anything seen in known solar system comets, and the newer methane-based measurements pushed that story even further, suggesting the comet likely formed in an extremely cold environment at some point in its very distant past, possibly in the outer reaches of a young protoplanetary disk, or even further out, in the cold molecular cloud material that existed before any star had fully ignited nearby. It was not only Webb doing this detective work. A separate team using the European Southern Observatory's Very Large Telescope in Chile, led by astronomer Cyril Opetam, examined a different chemical fingerprint entirely, looking at the ratios of carbon and nitrogen isotopes locked inside a molecule called hydrogen cyanide escaping from the comet. That study complemented Webb's findings and added another independent line of evidence pointing toward the same conclusion, that this object formed somewhere fundamentally different from anywhere in our solar neighborhood. One of the researchers involved in the work summed up why this matters beyond just curiosity about one comet, explaining that finding these rare isotopes is fascinating on its own, but the bigger picture is what it tells scientists about the possibility of prebiotic chemistry happening elsewhere across the galaxy, the same basic chemical building blocks that, here on Earth, eventually led to life itself. Webb was not the only instrument studying this comet. NASA's Hubble Space Telescope observed 3I/ATLAS both shortly after its discovery and again after it passed the Sun, helping scientists pin down the size of the comet's solid nucleus buried underneath all that glowing gas and dust. Estimates shifted a bit as more data came in, but the most refined measurements put the solid core at roughly 2.5 kilometers across, noticeably larger than either of the two interstellar objects discovered before it. A bigger nucleus meant more surface area available to heat up and release gas, which meant a brighter coma, and ultimately a stronger, clearer chemical signal for instruments like Webb to lock onto, U. Because 3I/ATLAS was moving on such an extreme path, and because it turned out to be surprisingly large and surprisingly old, some corners of the internet ran wild with speculation, throwing around theories that it might not be a natural object at all. When something unusual shows up from outside our solar system, it is a completely normal human reaction to wonder what else it could be. Scientists took that curiosity seriously, and instead of dismissing it outright, they actually checked. Researchers pointed radio telescope arrays specifically designed to search for so-called technosignatures, meaning any kind of artificial radio signal that might suggest an object was built rather than formed naturally, directly at 3I/ATLAS during its journey through our solar system, and listened carefully across a wide range of frequencies. The result was clear. No artificial signals were detected anywhere at any point. Every single piece of data collected across every instrument, from Webb's chemical fingerprint to Hubble's imaging, to the deuterium and isotope measurements, to the radio searches, points to exactly what an ancient natural comet should look like. Its behavior matches known cometary physics. Its chemistry, while genuinely unusual and record-breaking in places, fits within the range of what scientists expect from an icy body that formed around a different, much older star, under much colder conditions than anything in our neighborhood. Its structure, its coma, its gas emissions, its dust, all of it lines up with a natural interstellar comet, not anything constructed or artificial. I bring this up not to dismiss curiosity, because honestly, the real verified science here is already wild enough without needing to add anything to it. A confirmed visitor from another solar system, possibly 10 to 12 billion years old, carrying a chemical fingerprint frozen since before the Milky Way even looked the way it does today, studied directly by our most advanced space telescopes. That is already one of the most remarkable natural discoveries of the decade. It does not need embellishment. The truth here is stranger and far more grounded than the rumors. So what does all of this actually mean going forward? And why should it matter to someone who is not an astronomer? For one, every interstellar object we get the chance to study up close gives scientists a genuine physical sample of material built somewhere else entirely, around a star system we will likely never visit or directly observe in any other way. Instead of only theorizing about what other star systems might contain based on distant starlight, an interstellar object, let's scientists directly measure the raw ingredients that built planets and comets somewhere else in the galaxy, under conditions that existed long before our own sun was even a thought. That is an extraordinarily rare opportunity. We have only had 3 chances like this in all of recorded history, and 3I/Atlas gave scientists by far the most detailed data set of the 3, largely because of its size, its activity level, its extreme age, and the sheer amount of advanced instrumentation available to study it compared to what existed back in 2017. There is also a bigger scientific picture forming here. Each interstellar object we detect adds to our understanding of how common these wandering ancient bodies actually are throughout the galaxy. For a long time, scientists debated whether interstellar visitors were incredibly rare, one-off events, or whether space is actually full of them, quietly drifting past us undetected, simply because we lacked the tools to catch them. The fact that we have now confirmed 3 of these objects within less than a decade, with detection technology still improving every year, suggests these visitors might be far more common than anyone originally guessed. As newer, more powerful survey telescopes come online, scientists expect the detection rate to climb significantly. 3I/Atlas may not be some rare once-in-a-lifetime event. It might just be the 3rd confirmed sighting in what becomes a fairly regular stream of ancient visitors passing through, most of which we simply have not had the tools to catch until now. Let's take a moment to really sit with the full timeline of everything this comet has been through, because I think it puts the scale of this discovery into real perspective. This object formed somewhere between 10 and 12 billion years ago, around a star that almost certainly does not exist anymore, in a region of the galaxy that may look completely different today than it did back then. At some point in its ancient history, a gravitational interaction, perhaps a close encounter with a passing star, flung it out of that system entirely, sending it drifting alone through the emptiness of interstellar space, with no star to orbit, no light to warm it, just endless cold and silence. For roughly 10 billion years it drifted like that, tumbling through the space between stars, completely untouched, carrying its original chemistry locked away and frozen, its deuterium ratios preserved like a geological record of conditions that no longer exist anywhere nearby. Then, purely by chance, its long silent journey brought it close enough to our sun for our solar system's gravity to finally bend its path, and for our telescopes to finally catch sight of it. It swept past the sun, warmed up just enough to release some of that ancient frozen material into space, giving our instruments a brief window to study it, and then it continued on its way, heading back out into the depths of the galaxy, likely never to return, possibly never to be seen by anyone again. Think about that against the full scale of human history. Telescopes themselves have only existed for around 400 years. Space telescopes capable of reading the precise chemical fingerprint of a comet have only existed for a few decades. Out of the 10 billion years this object spent drifting silently through the galaxy, it happened to pass close to our sun during the exact narrow sliver of human history when we had both the knowledge to recognize it as interstellar and the technology to read its chemistry in real time. A few hundred years earlier, and it would have simply been an unexplained smudge of light in the sky, if anyone had even noticed it at all. We happened to be alive, with the right telescopes pointed at the right patch of sky during the one brief moment this ancient traveler passed close enough to notice. That is an extraordinary stroke of cosmic timing, and it took enormous coordination and engineering across multiple space telescopes and observatories worldwide to make the most of that narrow window before the comet faded from view for good. Scientists are still analyzing the full dataset collected from 3I/Atlas, and more detailed findings are expected to keep emerging over the coming months as researchers dig deeper into everything Webb, Hubble, and the other instruments managed to capture. The findings so far have already been formally published across multiple peer-reviewed journals, including Nature and the Astrophysical journal Letters, confirming both its ancient origins and its record-breaking chemical signature, cementing its place as the most thoroughly studied interstellar object humanity has ever encountered. Every new detail adds another piece to a much bigger puzzle about how solar systems form, how common these interstellar wanderers really are, and what other star systems out there in the galaxy might actually be made of, and possibly what conditions elsewhere in the galaxy might be capable of building the same prebiotic chemistry that eventually gave rise to life right here on Earth. If this story genuinely gave you a new appreciation for what real verified space science can uncover, make sure you're following this channel, because we are going to keep tracking every confirmed development on this story and every other major discovery like it, as the data continues rolling in. Share this with someone who needs to hear the actual truth instead of the wild theories floating around online, because the real story here is honestly more incredible than the rumors ever were. To wrap this up simply, in the summer of 2025, a fast-moving object was spotted heading through our solar system. And within days, scientists confirmed it was not from around here at all. It was the 3rd confirmed interstellar object in recorded history, moving on the sharpest, most hyperbolic path scientists had ever tracked. Early estimates suggested this ancient comet could be somewhere between 3 and 11 billion years old. Newer measurements published in June of 2026, based on fresh Webb data capturing rare deuterium and methane signatures, pushed that estimate even higher to somewhere between 10 and 12 billion years old, nearly 3 times the age of our entire solar system. As it swept past the sun in October of 2025, it heated up and became active, releasing gas and dust our most advanced telescopes were finally able to study directly. Webb captured detailed chemical readings showing unusually high carbon dioxide, the first ever direct detection of methane from an interstellar object, clear water vapor, a rare signal from nickel, and deuterium levels roughly 30 times higher than any solar system comet, evidence of an origin colder and older than almost anything ever measured up close. Hubble pinned down its size. SphereX, the very large telescope, and ground-based radio arrays added more chemical detail, and dedicated searches for artificial signals came back completely clear. Confirming this is exactly what it appears to be. A genuine, natural, ancient piece of another solar system passing quietly through our own before heading back into deep space, likely never to return. That is the real story, backed by real data from real telescopes, gathered by real scientists working together across the globe to make sense of one extraordinary visitor. And it is stories like this one, grounded entirely in verified science, that this channel exists to bring you first. Follow now if you have not already. Drop a comment telling me what part of this surprised you the most. And share this with someone who would find this as fascinating as you clearly do. We will see you in the next one.